Okay, so we're going to use a hundreds board to list all or find all our prime and composite numbers. So I've already marked the number 1 as being neutral. Number 1 is considered neutral because it is neither prime nor composite, because you use the number 1 with every factor that you make, whether it's prime or composite. 1 is always the first factor. I've marked the number 2 as being our only even prime number, because the only way to get 2 is 1 times 2. So 2 only has 2 factors, so therefore 2 is prime. Okay, now looking at this hundreds chart, and we're going to use our divisibility rules to fill this in. So the first rule was the rule for the number 2. And 2 says if the number is even, it's divisible by 2. With the exception of the number 2, all of these 2's, all of these with the 2 at the end anyways, are going to be composite numbers because I can divide them by 2 evenly with no remainder. Okay, the next even number is 4. 4 all the way down. These are all composite numbers. I can divide them by 2 evenly with no remainder. Okay, after 4 comes 6. From 6 all the way down are composite numbers because I can divide them evenly by 2. Okay, the next number after 6 is 8. All of these numbers are going to be divisible by 8 because they are by 2 because they end in an 8, which is an even number. So all of these numbers are divisible by 2. And finally, the last one is 0. Everything that ends in a 0 is divisible by 2. Now, we also said that if it ends in a 0, it's divisible by 5. So the next rule I'm going to look at is the rule for 5, which says if the number ends in a 5 or a 0. Well, I've already got all the 5's, all the zeros marked out, so I'm going to go to the 5 row. But I have to stop for a second. 5 itself is a prime number because the only way to equal 5 is 1 times 5. So I have to start at 15 and go down. So from 15 all the way down to 95, these are composite numbers because they end in a 5, so they're divisible by 5. Okay? Now, the next rule is the rule for 3. The rule for 3 says if the sum of the digits is divisible by 3, then the number is divisible by 3. So I'm going to just go down each column because that'll be quicker. Okay, 1 plus 1 is 2, not divisible by 3. 2 plus 1 is 3, so that one's divisible by 3. 3 plus 1 is 4, nope. 4 plus 1 is 5, nope. 5 plus 1 is 6, yep. 3 goes into 6 evenly. 6 plus 1 is 7, nope. 7 plus 1 is 8, nope. 8 plus 1 is 9, yes. 8 plus 1 is 9, so 3 goes into 9 evenly. All right, then we're going to go back up. We're going to go down the 3rd column. Okay, 3, the only way to get 3 is 1 times 3, so that one's a no. 13, 1 plus 3 is 4, so no. 2 plus 3 is 5, no. 3 plus 3 is 6, yes, 3 goes into 6 evenly. 4 plus 3 is 7, nope. 5 plus 3, 8, nope. 6 plus 3 is 9, so that is divisible by 3. 7 plus 3 is 10, no. 8 plus 3 is 11, no. 9 plus 3 is 12, so yes, that is divisible by 3. Okay, next column is 4, and that's all the way done. 5, we already said was prime, and the rest of the column is done. The whole 6th column is done. So now we have to go to the 7 column. 7 is prime, because the only way to get 7 is 1 times 7. Okay, 17, 1 plus 7 is 8, so nope. 2 plus 7 is 9. So 3 goes into 9, and so does 9. Okay, 3 plus 7, 10. So nope. 4 plus 7 is 11. So no, that's not divisible. 5 plus 7 is 12. So that's divisible. 67. So 6 plus 7, 13. Oh, sorry, 13. So nope. 7 plus 7, 14. So that one is not divisible. Okay. Next one is 87. It's 15. So that one is divisible. And then 9 plus 7 is 16. So it is not divisible. Okay. All right. Next row is the 8s, and they're all shaded in. And the final row, the next row is the 9s. 3 goes into 9 evenly, so that means the number 9 is going to be a composite number. 19, 1 plus 9 is 10, so no. 29, 2 plus 9 is 11. Nope. 39, 3 plus 9 is 12, so it is a composite number. 49, 4 plus 9, 13, so nope. 59, 5 plus 9 is 14, so no. 69, 6 plus 9 is 15, 3 goes into 15. 79 is 16, so nope. 89 is 17, so nope. And 9 plus 9 is, for 99 is 18, so yes, 3 goes into 18. So we kind of did the 3s and the 9s together because they both, it's the sum of the digits. If it's either going to go into 3 or it's going into 9. And if it's going into 9, it's also going to go into 3. Okay? So I have a few numbers on here that did not get shaded in that we need to look at, because then we have what we call tricky 7. Okay? Tricky 7, because it doesn't have any specifics, we just have to kind of guess and check. Well, one way to do that is just count 7s. Okay, so 1, 2, 3, 4, 5, 6, 7. 7 is a prime number. So I'm going to start at 7. I'm going to count 7 more. 1, 2, 3, 4, 5, 6, 7. So that's 14. Then that was already shaded in. Okay, 1, 2, 3, 4, 5, 6, 7. So we're back at 21. That one's already shaded in. 1, 2, 3, 4, 5, 6, 7. We're at 28. That one's shaded in. 1, 2, 3, 4, 5, 6, 7. We're at 35. That one's shaded in. 1, 2, 3, 4, 5, 6, 7. We're at 42. That one's shaded in. 1, 2, 3, 4, 5, 6, 7. We're at 49. That is a composite number. 7 times 7 is 49. Okay, 1, 2, 3, 4, 5, 6, 7. 56 is shaded in. 1, 2, 3, 4, 5, 6, 7. 63 is shaded in. 1, 2, 3, 4, 5, 6, 7. 70 is shaded. 1, 2, 3, 4, 5, 6, 7. 77 should be shaded in because that's 7 times 11. 1, 2, 3, 4, 5, 6, 7. 84 is shaded in. 1, 2, 3, 4, 5, 6, 7. 91 needs to be shaded in because that is 7 times 13. 1, 2, 3, 4, 5, 6, 7, 98. All shaded in. That means everything else that is not shaded in are your prime numbers. So your prime numbers are 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, 47. 53, 59, 61, 67, 71, 73, 79, 83, 89, and 97. Those are your prime numbers. Okay, so the ones that are circled are our prime numbers, and the ones that we colored in green are composite. Okay, since you don't have, those of you at home, since you don't have the tic-tac-toe board, I'm sorry, not a tic-tac-toe board, goodness, since you don't have the hundreds chart, if you will just list the prime numbers, you don't have to list all the composite numbers, but list all the prime numbers, the ones that are circled in red, and then list